Okay. Yeah, so who wants to start off this week? Devin, you've already got notes in there. Would you like to kick us off?
All right, I'll go for it. So yeah, just remind myself of these notes. Yeah, so I went through the GeoSci labs and updated that to run on base simulation branch. So that's finished. And while I was doing it, I found a little bug for how the 2D fields are being computed and kind of fixed that for DCIP. So
Nice.
glad that got pulled in, and then looked at some suggestions for the simulation tutorials review. So thanks guys for giving a review on that. So and then yesterday I got into contact with Soggy and Dom and started to look at transferring the EM1D stuff into SimPEG. It's living in a separate repo. So basically right now I'm working in that EM1D repository and yeah, making it work on simulation and simulation branch. And then I'm going to kind of finalize the class structure and get it more in line with what SimPEG does. And when that's complete, then actually move it into the SimPEG repository. I think that's the decision that we came up with when we brought this up for the first time. So that's kind of what I'm doing now.
Great. Well, that you'll find like that code is not general at all. So
No.
it is very specific to a very specific problem. So I am pretty open to any suggestions and in the chat.
Yeah, still looking at like a plan of attack. I mean, all the stuff is there. It just kind of needs to be organized in a way that is SimPEG-y.
Right, and then this is probably an opportunity because it is not a discretized, like a kind of finite volume code. So it has like a different nature and different things to consider. So yeah, it'll be kind of interesting to make it a little bit more common. But
yeah, well, I guess the part that was interesting, what we kind of thought was, you know, are we? Yeah, so I mean, the time domain and the frequency domain code, they use so much of the same stuff, right? Like the time domain code is just solving at a bunch of frequencies and then using filtering to give you the time domain response. So yeah, to separate them didn't make much sense if they're using so much of the same stuff. So there were sort of some decisions on, well, do we try and partition it and put them in the frequency domain and time domain I guess classes, or do we just make an EM1D class? But we're not there yet, right? There's still a lot of work that needs to be done just to kind of
like it inherits the base EM1D class. Like
yeah, so yeah.
It's kind of inheriting, like, so as you said, there are a lot of sharing part in time and frequency. So like it has a base class, and then it just inherits whatever needed for frequency or time in the like a frequency domain class and the time domain. I think it's similar.
Well, that was another option, is make like a base EM1D inside electromagnetics, so that you could just use that. You could call that, because it would be nice if you go into frequency domain in SimPEG and then it's one of the options in there, right? Trying to follow the same kind of way of getting at stuff that we have with 1DMT and the 1D DC resistivity, so that when you're looking for stuff, you're always looking for it kind of the same way.
This is one to think through too, is I'm certainly not settled in my mind actually as to where we should move EM1D. Like in some ways, I wonder if it makes more sense inside of something like GeoAnna. And we could still, I mean, SimPEG depends on GeoAnna, so we could still have it basically be imported, like importable from SimPEG. But I'm not entirely sure where we should have basically more of these like semi-analytical approaches living. Is do we want to keep growing sort of the SimPEG repository, or do we want to have them stored some, like that sort of family of solutions stored somewhere else? And so I think it's probably worth like sketching out a few different scenarios before we think about exactly where it should move. Because yeah, I'm certainly not like, I don't have those pros and cons kind of clear in my head yet. And I don't know if anybody else does.
Well, me neither. But I think that kind of the first to do is like kind of being compatible with the current simulation branch.
Yeah.
So like doing that is pretty clear, but we can decide where to put later, I guess.
Excellent. Thanks, Devin. And thanks again for all of your work on those tutorials. I'm really excited that we'll be able to be getting those out soon, hopefully. Any other updates, or is that pass the torch?
No, that's basically it.
Excellent.
And maybe quick to the EM. Which component are in SimPEG EM 1D at the moment, Sophie?
Oh, I think you're muted.
It is only the vertical component of the horizontal loop. That's it.
Because then when we think of how to bring that into SimPEG, we might at the same time plug in their EM-PyMod 2, or think about it when it's getting plugged in, that we could access EM-PyMod for the other components.
Right. So I think there are quite a few things, because you really want a general code, like kind of handling all the components and all problems. Like changing to EM-PyMod is much better way, and it's actually much general. And then we can like just use the finite difference for sensitivity computation. That's one pathway, but I think this code was really designed to handle like airborne EM data, like a large scale airborne EM data. So I'm fine with like to be very specific, because it has a purpose and like it serves the purpose. So I don't know, and yeah, I'm not sure that I really want to generalize that code to handle lots of different things. I thought that's like a little bit more valuable.
Well, yeah, I mean, this SimPEG, right? It sounds like it's trying to serve 2 or 3 purposes, right? It's an excellent learning tool. We want that for people, and then academic research, and then yeah, practical usage. So I understand the motivation behind using this this EM1D code is that you want to be able to get a result to interpret very large scale airborne data, but at the same time, we also don't want to, I guess, avoid catering to the other 2 audience, like the academic research and just being able to use it for learning.
And I like what I meant focus is not necessarily like a large scale. It's very problem focused, because if you think about like a use of inductive source in general on the land case, it's mostly a horizontal loop, and basically like at the center of the loop. And that's the majority of the use case. So, I mean, if you can hit most of the use case, you're not only like a kind of hitting like the large scale problem, you also kind of provide a research tool that they can play with the very simple tools. So yeah, so I mean, it's a kind of trade-off, like are you going to choose the generality or kind of being very specific? I don't know, I chose the former, but I'm pretty open to change.
But I mean, I think that it's, so to Devin's point, I think it's fair to sort of see that there are elements of sort of general aspects of SimPEG as sort of a research toy and things like that. But I don't think like every piece of SimPEG needs to actually satisfy all of those constraints, right? If SimPEG EM1D really is solving a practical problem, then maybe it doesn't necessarily make sense to pull it into the SimPEG repository, but have very clear installation instructions and sort of start to define an ecosystem around SimPEG of other codes that interface to it. And so like that's one potential trajectory forward. And in some ways, I kind of like that idea as more like a plug, like basically like a SimPEG plugin effectively, and show how to do that. Because that's in some senses how I would see interfacing to EM-PyMod as well. Is it doesn't make sense to like, you know, bring EM-PyMod into SimPEG, but it does make sense to basically have sort of like a lightweight, if you want to be using the SimPEG inversion machinery and EM-PyMod forward modeling, like here's how we make that connection.
Potential pathway, I think, because it has a two parts, like basically handling a single sounding. So it's like a truly 1D problem. And then there's the other level, calling that 1D function and like as like a lots of 1D problem. So we can break that apart and then put the truly 1D solution either SimPEG or in GeoAnna, and then just break that apart like those like inversion functionality to handle large scale data into a separate repo or something like that.
To me, it sounds a little bit like just patching. I mean, ideally, I think we just want to bring it in because installation is going to be complicated if people want to do 1D code and they need the Conda Forge for SimPEG, but not for SimPEG EM1D. Just do it. I mean, why are we just bring it in? It's not that much work.
Yeah, I agree with Dom on this. Like, I've seen people run into issues when they're trying to manage too many packages and too many dependencies.
This is, I think, though, I mean, and I would be curious to get Joe's take, but if we get SimPEG EM1D up on Conda Forge, I think we could solve a lot of this pretty readily.
Like, is it just a speed thing? Is because we want to absolutely to have like EM1D like as quickly as possible? Because I mean, it has been available for a while now. I think it's just a matter of like cleaning it up and bringing it to the main frame. But I don't know why we want to drag on with like an older implementation if the latest and brightest of SimPEG is going to be the simulation, the simulation class. So I don't know. We still need if SimPEG moves on and we get rid of the problem, then SimPEG EM1D will need to be updated anyway to be able to keep track of it. So it needs to be updated regardless, right?
Yeah, absolutely. No, and I wasn't advocating that we don't update it. It's just my question is more so what's the home that makes sense for it? That's all. But yeah, I completely agree that we need to go forward in any case with getting it updated. Cool. Okay. And maybe with that, we can even start either like a discourse post or even a GitHub issue just to like think through some of where its home might be. And we can follow that up.
Yeah, I mean, one of the benefits of bringing it all in under the SimPEG umbrella is it's a central location where somebody can go and find everything. You want to learn how to do some modeling in 1D or something like that, and then you're in the SimPEG website, you're trying to look at that, and then it doesn't exist in SimPEG, so then you're going to get thrown to another website that's going to have to explain the 1D stuff, and you're bouncing around a little bit for information. It's kind of nice to just have everything kind of in one spot, and have the documentation be in one spot is also kind of nice.
Yeah, I mean, I think like, so I really like the way that Leo's broken up parts of the Fadiendo project. And so there is one landing page for the entire project, but then each piece of the project has its own scope. And so there's a specific documentation for that. So I think there's potentially multiple trajectories through this. Because like one thing that I think has been really positive with breaking discretize out of SimPEG is now we can iterate independently on discretize and then have that update. And so like there's I think there's ways we can think through it without fragmenting too much, but I think that's a very valid and very fair concern that we should like seriously consider as we figure out where its home should be.
Okay, so then going forward, just so that I'm not wasting time, it would be good to continue what I'm doing, to be working in the EM1D repository, to basically refactor this into a class system that that mirrors what is being done in SimPEG. And really the decision that we're going to be faced with eventually is how we want to call it and where does it live in the end. But right now, what I'm working on is still useful and it's still what we need to do.
Absolutely, absolutely. So the
Okay.
function of where it lives can be later on. So as long as those changes are self-contained in the EM1D repository, and if there's anything that needs to be updated in SimPEG, that's fine. But let's not tangle them quite yet.
Yeah, okay. I just want to make sure that I'm doing work that isn't going to be either undone or is redundant. So yeah, I'll continue just kind of.
Definitely not redundant, and definitely quite necessary. Thanks, Dev. Perfect. Who would like to go next?
Well, I got just a quick update. Yeah, I've been tied up with a little bit of field processing, debug, and that interface for SimPEG and whatnot for our in-house stuff. But I have been tackling the sensitivity matrix for the MT stuff. I've just been taking what we talked about there on Thursday, how to break up the sensitivity calculation, storing the P matrices to a hard disk, and then going through just in chunks and calculating everything. It's not necessarily, say, the fastest, but it is certainly a lot cheaper. It was just for like the model that I was using, it was about 60 gigs of RAM to calculate the sensitivity, and I've got it down to about 10, 12 by just storing those P matrices and stuff like that. Yeah, so just pretty much debugging that. I think I just got something wrong with when I'm putting all the matrices back together, but everything's looking pretty good. Should have that finished hopefully by next week. Or something to look at and see what see what Joe thinks if he wants to take a look.
So, John, are you storing those sparse matrix? How are you storing those sparse matrix? Because it's like most of those projection matrix are sparse, right? So how are you storing that?
Just storing them as is to ZAR.
Okay. And is ZAR like a good, because like the worst case, if you think about like, oh, we've got a sparse matrix that stores as a dense matrix, that that generates a huge memory. Or so I was just kind of curious because like, I mean, we could be pretty smart about storing the sparse matrix, just like not like store the non-zero elements and the indices. And regenerate the sparse matrix when you're loading up. So I was just when they're receiving sparse matrix.
That's a good point. I'll have to look into that a little bit more. I was looking at, so saving all the P matrices and even the J submatrices, my folder is about 3 gigs or something like that. So it either compresses really good, or maybe it is just saving the non-zero entries. I'll have to take a look at that, but that's a good point. But yeah, whatever I'm storing to hard drive or the hard disk, it's significantly less. But yeah, I'll take a look. And then I guess I started up on Discourse there, a chat with Alex again. Yeah, I'm just a little busy this week, but I should have something to him by Friday. And but yeah, well, things are going forward on the Aurora stuff there.
Excellent. Thanks for doing that, John.
Yeah, no problem.
Sally, do you have any updates?
Actually, related to the SimPEG EM1D, there's like, I think there's a potential avenue that we can really sell hard to this California. So they are like in the planning stage to actually scale up the airborne survey to entire Central Valley. So, and we are actually just discussing, what are the tools that we're going to use to handle and process the data. And so we're a little bit competing with the Aarhus, because they keep pushing to use their commercial software and commercial database. So I'm just like trying to sneak in and like keep saying, there's sort of software we can use and it's freely available. And yes, actually Rosemary mentioned, we can potentially hire a software programmer to make that code more usable to kind of end users. So I think I'm not 100% sure at the moment, but I think that there's a potential. So actually doing like this work for like bringing into simulation branch and making it more clear, it'll be really kind of helpful to move that onto that kind of next level. because the idea here, like when they're going to acquire the data, and now actually they're getting clear, they probably have a chance to revisit their data again. So I think they want to be prepared to be equipped with having tools and also personnel that can run the code to have to recover a resistivity model from the airborne data they've got. So yeah, I think here there's a real opportunity that we can kind of bring in SimPEG into this kind of water problem in California. So yeah, I'm quite looking forward to it.
That's great, Sagman. Is there any chance that if you create an application for it, would be open, or would Rosemary want it to be canned?
Rosemary said, "Oh, I'm gonna contact to Doug." So there could be an internal connection that can be reached.
Because I started working on that app, right?
Yeah, I was thinking about that. So I think could be win-win there because you've already worked on, so we don't have to redone anything like that.
Yeah, you could use a GeoH5 as a database structure.
Right, and then they don't actually have any like visualization tools. So
there you go.
Yeah, I mean,
let's talk now.
Anyway, so I mean, there's a potential.
Yeah, I think that's kind of an easy path forward for you guys.
On that topic there, Dom, do you happen to have a little paper or anything on the format of the GeoH5? We were thinking that we were going to output our databases to that file format as well to make things easier.
Yes, so there's I'll post the link. There's a Git, there's kind of like a document on GitHub to you know how it is, but it's a little bit rough. I think I can help you. It's not that complicated, but it's not that easy to understand if you read a document. It's probably easier if you read the Python code than if you read the document. I'll post it on the link now.
So just like I'm curious. So if you want to just store the data and then corresponding metadata related to the data, GeoH5 is a good kind of way to go.
Yeah, it's basically an HDF5. It's an HDF5 file, but it's just structured so that you can store, you know, metadata and different type of geophysical data. You know, like it knows what a line is, it knows what a point is, what a block mesh is, that kind of stuff, right? So it's basically just a prepackaged HDF file. Yeah.
Yeah. Okay.
So it has compression, right? So it's a pretty wide format.
Right.
Yeah.
Right. So do you think that's actually quite sustainable solution? If you kind of generate the database with the GeoH5, it's pretty sustainable.
Well, the beauty is that you don't need anyone after this. You could use like third-party, you know, database management that can handle H5. So you're not you know bind to like any specific service provider. Once it's written, it's just an open format, so you can still read and write to it.
Okay.
Sagi, is the plan for it to be, so just one like extension to consider? I think H5 is probably quite sensible, but also if they do want to actually have this running on the cloud and stored on the cloud, XAR is a better format for that. But there's some sort of like, in a sense, you can write an API that can access either XAR or HDF5. So as long as you're using the same like internal structure for the data file, then that's fine. But that's just something to keep in mind, is if it's going to be on the cloud, you probably want it to be .xar, which is also
right.
And Dask handle both, right? We could technically read from H5 and then save parts of it to XAR if you want to do something fast in parallel. So we could easily go back and forth. You know?
Yeah.
That sounds good. Yeah, so we're like just kind of finalizing our project, and the final step is, okay, how are we going to archive the data and make it accessible and reproducible? So yeah, just like kind of what are the options and trying to figure out. Okay, that sounds actually good.
Oh, Doug, I think you're muted.
Do you have a sense about the timescales in which you know, major decisions would need to be made about the use of the software and how the how the processing is going to go?
Well, I think I would say in a year. That large scale project will start next year. So I mean, it's coming soon. So yeah, I think decision needs to be made like about a year. And I think they would like consider multiple solutions, not a single software. So they would consider multiple things. But I think if SimPEG could be a one option.
And Sagi, is there anything that we can do sort of on the SimPEG side of things, even with the website or the documentation, that you think would be helpful for sort of
Yeah, so I think working with Devin, I think kind of, so actually writing up the documentation and how things working is very helpful, because currently it's almost a black box code that I can only use it or a few other people who knows how to use it. So yeah, so it'll be great to have examples and how things are working. And so we have this 3 pilot studies that we've done. So I'm hoping, like, if I have a time, I'm hoping to kind of make that as an example, and then choose whatever data format, store in as a nodo, and then kind of like point that, oh, it's there and the code is here. You can run that. That types of example, like I'm kind of hoping to work on. So that'll be quite useful.
Excellent. Yeah, I mean, if there's other things that come up, and even if you think of stuff that would be helpful to have on like SimPEG.xyz, like the main landing page, that would help tell the story, we can definitely prioritize some of those things, because it would be fantastic if SimPEG is at least one of the potential avenues in this project.
And other thing, I actually like kind of successfully used the STEM's LP norms in the EM problems. I had quite a few issues, like I tried like a DC and EM problems quite a few times, but it was quite subtle before. And what ended up problem was I haven't used a sensitivity weighting. And the other thing was also the parameter, like default parameter maximum CG and the tolerance of CG. So that like so I think that I haven't recognized like this LP norm inversion is like combining of all of those parameters. When I think that all parameters are set properly, it seems working quite well. Anyway, so like if you're just simply using default parameter, that's quite subtle. But anyway, I could show one example. So I'm interested in this what they call Corcoran clay. That's if you do a smooth inversion, that's what you would recover. But like it's about 100 meter thick, 100 meter depth, but it's not going to be 100 meter thick. But what they really interested, what is the thickness, what is the extent, because it's actually a layer which dissect upper and lower aquifer. So it's a really thick clay which impede the water. So actually knowing this impeding unit is very important. So if you do a sparse inversion, that's what you would get. And here, what I have to do was I just like selected this portion here and just inverted those part, like just impose the sparsity on those part. So, okay, this clay unit is a sparse unit, and that's what you can get. And at the end, it's actually matching almost perfectly with the E-log. So I haven't used the E-log. Hit the right top boundary of the Corcoran clay. And you can actually get the depth and thickness of the clay layer. So yeah, I was quite happy with that. And finally things are working, so.
And you're doing dual moment here? You're doing both the high and low moment?
Yes, yes.
You'll need to show me how, man, because I got 2 requests already, and I just can't figure it out. So yeah, if we work on this together, that would be really helpful.
Yes, I mean the most like use case here is mostly SkyTem. I think they're thinking about other options, but
there's so much SkyTem being flown around, man. These guys are killing it. Like compared to all the data sets that I see, SkyTem is everywhere.
Yeah, I think they are actually serious about kind of to be like it being inverting those data. Other system, I'm not sure like how much effort they have put to get all this calibration right. So they actually have a test site. So what they do is they have like make a test site, then you got a resistivity model. You synthetically generate a synthetic data, and they flew over the test site and see if you can actually match those decay curve, and then calibrate, do a corresponding calibration. So yeah, it's quite impressive how serious they are. So yeah, my confidence is pretty high.
And it shows, yeah, the data is high quality.
Yeah, whereas other system, I'm like, sometimes I have a lot of these calibration issues, and you're trying to fit like both systems together, and it is usually you have a hard time to fit the data, and you don't really know whether that's a problem of calibration or what your code. So anyway, but so I actually tried like inverting the like different SkyTeam system flow in different times together. It's actually kind of pretty. I can fit the data pretty well by inverting both. So yeah, it seems actually pretty consistent.
They're consistent, yeah. I ended up figuring out the, you remember Sanders airborne EM frequency system I told you? Yeah. So after a lot of tweaking and going back to the raw file, man, I don't know what kind of filters they're doing on this. Kind of like levelings to make it pretty, but it killed everything. So I had to go back to the raw frequencies. It's a mess.
Thanks, Saki. Don, do you have any updates?
I reviewed with you, I guess, Joe's changes to the Dask. Right now, it's a Dask call. Fantastic work, Joe. Man, this looks amazing. Cleans up a lot of things.
Mm-hmm.
And yeah, the mag is back online, so all good.
Yeah, I was just
yeah, go ahead.
Hear that there was like no weird bumps in memory or anything. Like I didn't think anything I did would do that. Like everything I changed, I think wasn't going to change any of that. Or at least
I didn't look at this. Yeah, I'll rerun something bigger to see if it. I don't think it would. You just basically just combine stuff that were doing the same thing.
Yeah, and like. Yeah, just made some of them a little bit more general so they would work both ways, I think. It looks like it'll work both ways. Or test it both ways.
So when are we, I guess I can do it whenever, but I think one thing that I would like to bring in is the directive for the spherical formulation, because right now we're kind of running two inversions back to back, but I have a directive to do the spherical, so I think my plan this week is create a PR for that guy. It'll clean things up a lot more for the inversion part.
Nice.
That's it.
Thanks, Don. Joe, would you like to go next?
Sure. So I spent a lot of time the last couple days working through the documentation, making sure it all linked properly, built correctly without any warnings. So I've gotten all the SimPEG documentation now working. All of the plots and everything that runs inside of it are working. Yeah.
Thanks for doing that, Joe. That is such a big job.
All the links within the document are working. So things like, okay, well, you can click on numpy.ndArray, it'll bring you to that class on NumPy. Yeah, it's just basically it runs now without any warnings, without any errors. The warnings are kind of like just make it look nicer. I generally, moving forward, I would like to get them all in terms of NumPy documentation style. I think it's much cleaner. It's a much easier way to write the documentation, actually, and so not only it looks cleaner, not only within like the documentation or the Sphinx generated stuff, like that's separate. What I'm talking about is that it looks better if you like just look at the documentation. It's readable. It's like human readable instead of all this like, you know, semi or colon param colon something colon colon.
Yay!
Yeah. I'm looking into a few tools to kind of help us automate that. The biggest issue we will have is the documentation that's generated from the properties. And I just haven't thought about how to get on top of that yet. Maybe we'll have to submit some pull requests to properties to get it working.
Have you been in touch with Franklin at all on that? Or not yet?
Not yet.
Yeah, because we can actually, it might be worth us just kind of sketching out like what our game plan is and then see if he's able to help, or if not, like what the state of properties is. Because I mean, it hasn't really been updated at all recently. So I don't know if it's something he's still planning to maintain, or if we should consider asking about forking the project, those sorts of things. I don't know what the best way is forward, but that would just be a conversation, I think.
And so the things that we get from properties, right? We get automatic getters and setters and type validation, right? And then we also get the serialization from there, right?
Yeah.
Okay. So I'm just kind of curious, like if it would be worth it for us to like write some simpler ones that we just to do what we need to do. I don't know. I'm just thinking like it might be worth it as well, but I don't know.
One thing, I guess, since we're talking about this, is for the codes, let's say the frequency domain EM, like the 3D one, in the doc string under that class, you put how the problem is discretized, and then when you auto generate the API, you're going to have a lot of math kind of mixed in with what the parameters are to do that. I guess I wondered if people were really keen on having the formulation always be put in the doc string for that simulation, or whether or not it's better to put those in something more of like a theory section. I kind of prefer the latter. I think it makes the documentation for the API shorter and easier to find stuff.
You can always link to it in the API and the documentation for the simulation classes as well. I think that would be a good idea, actually.
Yeah, no, I agree. And then, yeah, if you're looking it up, then you just click and it'll take you to that. But I guess the first time going around and trying to learn SimPEG when that was all auto-generated, there was math and derivations and theory in there, and I guess I found it harder to get started with SimPEG. So yeah, ultimately I'm hoping we can move the information about the formulation to another place and then link it.
Yeah, and I think there's a lot of, oh, sorry, go ahead, Joe.
I don't think that should be a problem personally. Like I would also, as part of this, I'd kind of like to refactor almost most of the documentation as well. Like, so there's ways you can, at least for like the API, like the API documentation, I personally like to have that as part of like almost within the code. So like within the module initialization, like module init.pys, we can put a bunch of stuff in there. So it's like also not lost if someone's running it locally without having to look at the documentation, like without having to keep it up. I would like to reorganize how like the landing page of it, because right now there's like, okay, there's the modules and then there's like the API, even though modules are part of the API. Yeah. What were you gonna say?
Oh, I was just going to say, I think that this could be timely. I mean, I don't think we should like address this with the pulling in of the simulation, but it definitely should be on the list for shortly afterwards. But I could see this being quite fitting with thinking through basically some of the updates we're making to EM GeoSci, and also potentially thinking about like what an inversion style resource should look like, and what things we want to link out to. Basically, how much theory should the SimPEG docs hold? I think is a good question, and that's something like as we think through what these other like online resources look like, or should look like, sort of how to strike the right balance so we're not kind of repeating too much content in one place or the other.
Mhm.
Are there any things, Joe, with respect to getting things ready to go with the merge that we can help you with? Like I tried making like a project on GitHub just to kind of track what sort of issues we really want to have pulled in with this. So yeah, I don't know if there's anything else you think that is worth having a discussion about right now or worth folks jumping in on.
I mean, I put in the little notification, like I think that we had, at least the last time we had talked about the relative error, standard deviation, all that stuff. I think the names that we had like kind of converged on, I commented on in the thread, in the bug thread. I think we were kind of settling on relative error and noise floor, and then renaming uncertainty to standard deviation. At least that's what I think we had converged on. So that's the only other thing that I would like to get in besides serialization stuff that I'm sure Lindsay's going to talk about a little bit. But,
One question.
sure is there? I mean, that fix should, or that change should be pretty quick, just a batch rename of everything.
Yeah. One question, and I don't know if folks think this is confusing, and maybe we're actually fine because we've been working on the simulation branch the whole time anyways, but we do actually have the term standard deviation on the data class right now, and we're thinking about like giving it new meaning. Do you think that that's potentially confusing? Like, do we want to keep it as uncertainty for now, or do we just want to do this and be loud about it and move on? Because we are sort of, I mean, we're working on a branch that is basically just us.
Mm-hmm. I mean, I think I would be okay with just kind of going forward with it, just renaming it all, and then put in deprecation for what it used to be called in the original master, or in the master branch.
That sounds good.
I don't know what else other people who have been working with the simulation branch would think, but I don't think it should be, like, I'm not, like, I'd be fine with jumping all in.
That sounds good. Okay. Any other things, Joe?
Not that I can think of right now.
Okay.
I maybe would quick jump in on Joe with the properties. Do you think many things these days could be done with the newer decorators that are available now that SimPEG is not depending on Python 2.7 anymore? I don't know if most things could actually be done easier with modern Python.
So
those properties is not
yeah, I know what
actually
you're
required.
The decorators in Python, they're nice, but they don't enforce anything. They're just a suggestion to the user to, oh, it should be this type. I think what we're wanting is something that validates it as well when it gets set.
Yeah. Okay. So, yeah, that's it.
Dieter, do you have any updates you'd like to share?
Not much. I broke everyone's code apparently by pushing out in PyMod 2, but it was dangling there for a while and I just want to get it out because I then also refactored EMG3D a bit by renaming things in a way a bit more like SimPEG. So in the utils, it's now the maps and models and meshes and fields. I split that up initially, so maybe when I get around to try and use EMG3D in a SimPEG version, that it might be a bit easier.
Excellent.
So that was the reason I want first to finish the new PyMod version, to have them together. Yeah. Other than that, I'm still having fun with command line interaction at the moment. Dom?
Thanks to both you and Sag for for patching SimPEG EM1D so quickly. That was super helpful. People started trying to install that on different machines, and then everything broke. It's like, no, what's going on? So that's good. Everybody's back online. Thanks a lot.
And nothing broke. That's good, because it's quite different. I had a release candidate like for 2 months, and it never happened anything on my machine, but that never guarantees anything. So.
Excellent. Thanks, Dieter. Doug, do you have any updates?
No, not really. There's a couple things that have been brought up that would be nice to continue on after this meeting, but I don't think about anything particularly relevant really right at this point.
Okay. Thanks. I'll share a couple updates. I've been trying to actually do some coding again, which has been really nice. So I've been jumping in a little bit on just finding, there's a few little bugs here, bug reports that, folks have pushed on the SimPEG issues. And so I tried to just address a couple of those that I thought would be easy and nice to include with the simulation refactor. So there's a couple pull requests on there that have been started that are pretty lightweight. With the simulation refactor, Joe and I have been working on a blog post, and I put a Google Doc link in the notes there. And it's definitely still like a sketch, and there's, I think, some things that are missing. Joe made a good point that we should have a big section on the module renamings and just what things were and what they are now. But if there's other stuff that like you see that would be useful to add, or if there's things that as written are completely unclear, please feel free to make edits or suggestions and add yourself as an author. This is totally open to whoever wants to be listed on the blog post, and we can basically hopefully have that ready to go as soon as we do the release, so that it's pretty clear how folks can upgrade and what's all changed. Yeah, and then the other thing, as Joe mentioned, I've been working on the serialization side of things. I'm going to just try and basically systematically go through all of the simulations, and make sure that we can basically serialize receivers, sources, the survey, and then the simulation. And what's nice then is that that should then make it easy for us to basically do simulation.save or simulation.load. And so once you've done, once you've set something up, if you want to basically share a complete setup and just kind of get up and running, that should be a bit easier. But it does take just a bit of thought. A lot of it just is logic around how things are instantiated. So I might be firing some questions here and there just to make sure that things are consistent. So it's both how things are instantiated, and then what are the things that are properties with the properties library, because that is basically telling us what is being serialized. So what needs to be, the logic for what things should be on properties are basically what are the things that we need to be able to recreate this class. And so if there's anything that's computed, we shouldn't be serializing that. We shouldn't necessarily be serializing the gradient operator on a discretized mesh, but we should be serializing the underlying tensor mesh vectors. And later on, we can think through, if there are some things, as John was saying, if we do want to be saving things like projection matrices, if it actually makes sense that, we've already computed this once, let's just serialize it. And so I have them when I load back up. We can start to put some of those hooks in place, but at least for the first pass, it's very much just these are exactly what I need, the minimal set of things that I need to recreate this object. So there's that. Oh yeah, and then the last update, so Matt Hall reached out and asked if we'd do a tutorial at the transform workshop. So I said yes, so we're now on the hook. So we've got a 3-hour slot. And so what I think would be helpful, and I can start some of this and we can iterate together, but it's just to kind of sketch out what we would like to do. I had a bit of a Slack chat with some folks, and talking about basically, and I really like the suggestion of starting with real data, get an version up and running, from scratch, go, and then sort of once we've worked through an entire inversion, and hopefully, I mean, something simple, we can start with potential fields, the lightweight data set. Like we don't need to do anything too fancy, but show how we would work through that, maybe for 2 data sets or something like that. Do DC resistivity and potential fields to give folks a flavor of 2 different problems. And then basically after that, go and sort of unpack what happened and what all of the pieces are and what kind of knobs and things there are. So I'll start a document where we can brainstorm these things. And if anybody has data sets that we can distribute that you think would be a good candidate for this, that would be great if we can sort of nail those down early on. I was in some senses wondering if there's some, like for DC from the GWB project, that might be fitting. But other than that, we can think through what other sites would make sense. So,
Doug, do you have Century deposit DC and IP data?
It might require a little bit of a look, but they should be someplace. Yeah, that might be interesting.
I think here we should use like something high impact data where things really kind of make a kind of different perspective about geophysical data.
Yeah.
So if you have something kind of impactful data, it'll be interesting to use rather than just kind of a little bit random data.
Yeah.
That's a good point. I'll take a look. I mean, actually, it was kind of interesting that Joel Jansen brought that up at his BCGS meeting, because I don't think anybody's talked about Century for 20 years.
So anyway, if you have like a kind of some impactful historical data, I mean, that'll be really interesting to use in that meeting.
Yeah, so there's actually there's actually a few of them. The other one from the point of view of potential fields is Raglan. That made a huge difference in the geologic community, and I'm sure we have that. So a Century deposit for the DC and IP, and the potential fields with Raglan. I mean, those would be really great candidates.
Lindsay, who are the audience of this tutorial? Do you have some like a vague idea?
So you can sort of get a sense. I mean, it's helpful actually looking through the schedule and to see what other tutorials are happening. I think, so what Matt basically said is we should aim for sort of a beginner moderate level. And so, I mean, I imagine folks who are going to show up to a SimPEG tutorial have some interest in hopefully a little bit of background in inversion, but they might not have much. And so, yeah, we should plan for something that's reasonably introductory.
But do you think their background is geophysicists, geologists, I don't know, like hydrogeologists? Who are like sort of what
Both, all of them.
Oh, okay.
Yeah, but I think
and I also think from students to practitioners to, you probably could have everything in it.
Yeah.
Well, yeah, I guess this is one of the nice things about the style of tutorials that I was trying to design is they were done in a style where somebody would actually be trying to adapt the tutorial to complete a real project. So if you want the one for like a 2D DCIP inversion, and you want one for magnetics or something like that, it's kind of all there. So you could think about following through and reading the comments that are put down and kind of adapting that. I think would be probably a good way to do this quickly.
That would be great, and it'll be a great test run of us using that and working through all of the tutorials you put together.
Yeah, it just needs, I think to do a real problem, you would need to have an IO for a particular data format. But once that happens and you've set up the survey, like it's all explained there. So yeah, take a look. You might find it's probably not going to be much work to adapt it.
Excellent. That's great. Yeah, well, and I would encourage everyone to actually take a look at the lineup too. There's some talks that and tutorials that I'm super interested in showing up to. Like there's some geostats, there's also GemPy. So Miguel is going to give a talk. So I think some of these could be quite useful. So hopefully a few of us can get to a handful of them and yeah, share some learnings. Perfect.
Lindsay, will they be then recorded and be available on YouTube later on, or is this like a one pass through?
I imagine so, but I can ask Matt. I don't know for sure. Dieter, do you know?
No, I would guess it's the idea, but it's in the works. So yeah, no, I don't know.
So what is your role in this, Dieter?
I'm slightly involved in the hackathons at the first weekend and on the second weekend. Not too much in the whole session in between, just yeah, helping out.
Excellent. Perfect. Does anyone have any other items you'd like to bring up before we wrap up today?
And talking about that, if you want to do with SimPEG some hackathon projects, that might be a good idea to get people hooked on SimPEG.
That would be fun. All right. Well, thanks everyone. Have a good rest of the week and we'll see you online.
Yeah.
Devin, were we going to just stay on here, or were we going to get a new one?